Hi guys, so we're looking at day 11 here. We should be in unit 5, or I guess unit 6. We're looking at lesson 52 today, and we're doing order of operations. So, order of operations, I always remember the acronym. I know they've changed it because it's not perfect because of the way it's read and all that, but PEMDAS, I've heard people use GEMDAS because parentheses, there's more grouping symbols than just the parentheses. Also, kind of the jingle, please excuse my dear Aunt Sally. For whatever reason, that one's been used since the beginning of time. That's what I was taught with. But P references parentheses or any grouping symbols, and that could be, we have a big long, expression, a bunch of terms in a numerator. Even though we don't have parentheses around it, that's still grouped together because it's in the numerator or it's in the denominator. We have brackets, braces, parentheses, all of those are grouping symbols. Sometimes we have grouping symbols within grouping symbols, so we go to the innermost ones and start from there. E stands for exponents. So if we have numbers squared, or this would include square roots, cubed roots, so exponents and the opposite of exponents, which is roots. Okay, so again, sometimes we just say exponents, then we see this. Well, where does a radical sign fall in the order of operations? It would be along with exponents. So if they have the same priority, just like addition and subtraction or multiplication and division, we work left to right. Multiplication and division, they have the same priority. So just because we say multiplication first in the acronym or the jingle doesn't mean that we do it first necessarily. If we have a problem that has division and multiplication, okay, we may divide before we multiply. We just work left to right because they have the same priority. And then addition and subtraction, those have the same priority as well. So we just work left to right. So please excuse my dear Aunt Sally. Easy way to remember it, or PEMDAS. As long as you remember what each letter references, then that should help you out. Okay, so in a little bit lengthier explanation, simplify within parentheses are other symbols of inclusion from the innermost to the outermost. So if we have parentheses within parentheses, just work inside to out. Powers and roots, multiply and divide, left to right, and then add and subtract. Symbols of inclusions, just because normally we say parentheses, it could be any one of these in there. Okay, and the division bar in a fraction. So parentheses, if we have braces, brackets, or we have something in the numerator and denominator. So, for example, let's do. So if I had this, well, normally this is division, but since this is all in the numerator, I do that first before I divide. Yeah, normally we divide before we add, that's correct. But since all of this is in the numerator, I add and then I divide. So if it helps you, you can go ahead and draw in your own parentheses. Usually those won't be included, but we know we perform everything in the numerator. Or if we had another expression in the denominator, the same rule would apply. So 1 plus 3 is 4. 4 divided by 2 equals 2. If we did division first, well, then we would have, what are we dividing? The 1 by 2 or the 3 by 2? What are we doing? It would just obviously make it messy and give us the incorrect answer. So that's another form of grouping symbol, even though the symbols are more implied. There's the jingle we talked about. Please excuse my dear Aunt Sally. So if we have this example here, we have 2 plus 4 times 3 minus 4 divided by 2. Okay, well, we have addition, multiplication, subtraction, and division. So we know we multiply and divide before we add and subtract. So I have 12, okay, and then 4 divided by 2 is 2. And then we get down to where we have 2, which we didn't do anything with, the 12 now, plus 12, minus 2. Okay, so we add that. 14 minus 2 is 12. Okay. If we have this one here, 3 squared plus 3 times 5 all over 2. So okay, in the grouping symbol in the numerator, it's its own group, even though we don't have parentheses. And then within grouping symbols, we also have to follow order of operations in there. So we have 3 squared, which is 9, plus 3 times 5, which is 15. 15 plus 9 is 24. 24 divided by 2 is 12. Okay? So even though it's all within the grouping symbol, we had an exponent, addition, and multiplication within there. So within our grouped symbol or our numerator, we had to follow order of operations as well. You'll see questions like this on the test. It says evaluate and then give you A equals and B equals. So just plug in 3 for A since it's equal to 3, 4 for B, and then solve for it. So the two numbers next to each other, the two unknowns next to each other, that doesn't make it 34. It makes it 3 times 4. So 3 times 4 is 12. 3 plus 12 is 15. Okay, so we can write those next to each other. When we fill it in for our own, when we're evaluating and plugging in those numbers, we'll put in parentheses just so that we know it's not 3 plus 34, it's 3 times 4. So we multiply and then add. Calculators, obviously we moved into where we're using calculators. I would just be careful, and it'll be more down the road when we get really complicated or we have big long expressions in the numerator and then we're dividing over something. If we don't put it in exactly right in our calculator, it'll divide before it does stuff in the numerator because it's just seeing the last number or the last whatever term as being divided by whatever is in the denominator. So you can do it in your calculator. Sometimes it's easier to do it in chunks, like do the first part and then divide that answer by whatever is in the denominator. But we can do this in our calculator. It's just sometimes you get an incorrect answer, as I'll show you in class. And also our calculator distinguishes between negative symbol for negative numbers and then the negative symbol for subtraction. Okay, practice set we'll go over as a class. And then lesson 53, we're looking at ratio word problems. Okay, the ratio of parrots to macaws at a bird sanctuary was 3 to 5. If there were 45 parrots, how many macaws were there? So we're going to set up our ratio box and actual count just like we always do. It's 3 to 5 parrots to macaws. So we set those up 3 to 5. Then the actual count, just fill in the information we have. Then we set those up to where we can cross multiply and divide. 3 to 5 equals 45 to m. Okay, you can put whatever you want for that unknown. Cross multiply, we end up with 3m equals 5 times 45, which is 225. Divide, cross multiply, then divide by 3. M equals 65. Always look back at the original 45 to 75 and 3 to 5. Yeah, that looks like it makes sense. If we get a number, obviously 3 is the smaller number, 5 is the larger number. If this came out to be like 25 or something, we know that that can't be correct. So we'd want to go back and check our work. If we have in the auditorium a ratio of boys to girls 5 to 4, again, let's write down what we know. We know boys, girls, 5 to 4. It's our ratio. This will be our actual. If there were 200 girls, and sometimes we'll add in a third row down here of total. For this one, it doesn't look like we need it, but we could say 5 plus 4 is 9, and then find the total number of students based off of any of that information. So there are 200 girls. Okay, so we want to know about boys. So 5 to 4 is equal to the number of boys to the number, because that ratio doesn't change. This is just the most reduced version of whatever fraction can come up with. They're still equal, so we cross multiply. For B equals 5 times 200, which is 1,000. and we divide by 4. So we end up with 250. Okay, so cross multiply and divide. And again, looking at the numbers, 250 to 200, yeah, it's a little bit more than 200. 5 is just barely more than 4. So we know it's right. And again, this real world example, if we ever get like a fraction or a decimal or something that doesn't look right, number's too big or too small, and go back and check your work. Okay, we'll do these examples. So just set up your ratio box with the two, whatever you're comparing. Carrots to celery, boys to girl, students who ride the bus to students who don't ride the bus, whatever it is. And then your ratio and your actual count, fill in whatever numbers you're given, and then cross multiply and divide. Okay, lesson 54, we're looking at rate word problems. Okay. So it could be a long word problem, paragraph, page, could be a sentence or two. Okay, we'll just fill in what we know. If Mr. Gomez drives his car at an average of 55 miles per hour, how far will he drive in 3 hours? Okay, so we have a rate of 55 miles per hour. And we want to figure out how far is he going to go in 3 hours. So 55 miles per 1 hour, and he travels for 3 hours. So this is our rate that he's going. He drives for 3 hours. We want to know how far he's gone. So I do 55 miles over 1 hour because that's our miles per hour, and also because hours over hours are going to cancel out. Any number over itself or any units over itself, so hours and hours, denominator and numerator, those are going to cancel out. So I'm left with 55 miles over 1, or just 55 miles, times 3. And our units, we're going to end up with miles. So 55 miles times 3 is 165. So at this rate, for 3 hours, he's going to travel 165 miles. Let's look at example 3. Hannah works for 8 hours at a sporting goods store and earns a total of $68. What is her hourly rate? And then once we know that, we use that hourly rate to find how much she'll earn if she works 30 hours. So she earns $68 for 8 hours. Okay, we can simplify this. We're still going to be left with our same units. Dollars and hours. So we do 68 divided by 8. It's 8.5. So she makes $8.50 for every hour. Okay, so $8.50. So pay, we can set up our function. Pay equals 8.5 or 8.50 times the number of hours. So she's going to make that same rate, assuming there's no weekend pay or holiday or doesn't go to overtime or there's no sliding scale. So we want to figure out how much she's going to get paid after 30 hours. So we have our rule, the number of hours. This is a constant, it's not going to change. So we plug in 30 for H, number of hours. 8.5 times 30 equals $255. Okay, and then we'll go over that practice set when we return. All right, so we'll see you guys then.